Good morning and welcome to section 6.2. Yay! Now, we talked about rules of exponents in 6.1. Now we're going to be working more and more with what we call exponents. And we are entering into the world of polynomials. We're going to learn how to evaluate, add, and subtract today. And we're also going to learn certain vocabulary that's associated with these polynomials. So let's begin with the vocabulary. Now, the general definition, a polynomial in X is the sum, or it could be the difference, of a finite number of terms of the form ax to the n power. Now, a is going to be considered a coefficient, which is a number in front of x to the power of n. And n, this is crucial, is a whole number exponent. Now, when you go on to 482, that n is going to become a fraction exponent. That means something totally different. So here, anytime you have a fraction, we're not going to consider it a polynomial. Now, we also have some words to look at. It's called expression. The term 5x cubed plus 7/4 x squared minus x plus 9 is an algebraic expression. An expression has no equal sign. Okay? Now, inside this polynomial or algebraic expression, we have what we call terms. 5x cubed is a term. Positive 7/4 x squared is a term. Negative x is a term. And this positive 9 is a term. And you'll notice that I have plus and minus signs that separate. Okay? So technically, I have 4 terms. Each put together has a sign in the middle. Now, this algebra expression is known as a polynomial because we have powers of x, and they're different. Okay. Now, just as we saw before, you are going to see in ALEKS tables. Now, they're going to ask you to write and name each term. Now remember, coefficient is the number in front of the x to a power. And then we're going to talk about the degree. Okay? Now, the degree is the exponential power of each term. Yet, when all of these terms are put together, In a polynomial, the degree of the polynomial is the highest exponential power of the variable or variables. Okay? Now, notice in column 1, I put all of the terms from the algebraic expression just as they appear. Okay? Now, the positive sign for 7/4 and 9, I didn't include, but you'll notice for the negative x, I did include the negative sign. Because remember, anything without a positive sign is positive, but the negative, we have to know it exists. Now, when we look at each term, the degree is the exponential power. Now, 5x cubed has a coefficient. The number in front is 5. The degree is talking about the power of x. The coefficient for a positive 7/4 x squared is the fraction 7/4 or positive 7/4. Now, the degree is the power of x, but notice we've gone down to 2. Now, the term negative x, we have to remember there's a 1 in front. Mathematicians don't write that 1, and that is the coefficient. Now, the power of this x, remember, I don't write 1s. There it is. And the other part that's hard to understand is the term 9. Now, coefficient means it is the number in front of x to a power. Well, you have to remember x to the 0 is sitting behind this 9, which is why it has a 0 power. And remember, what does x to the 0 equal? 1. Do I write 1s? No. Okay. Now, more vocabulary. Now, this is something that up until chapter 6 you could have gotten away with. Okay. You are going to need to write your answers of all polynomials going forward in descending order based upon x. Now notice, this is 3, this is 2, this is the power of 1, and this has x to the 0. It is in descending order. Now, if you're asked for the degree of the polynomial, remember, it's the highest degree, which is 3. It comes from this very first term. Okay. Now, let's take a look. Let's go right here. Okay, we have our own problem right here. Okay, it says determine whether the expression is or is not. Now, if it is a polynomial, then we're going to identify the terms and we're going to state the degree. But remember what we said? Look right here at the last term. Do you see the a squared is the denominator of a fraction? Do you remember that I can write this as a -2. When I can write one of the powers as a negative exponent, this is not a polynomial. Remember, it's got to be whole numbers. It's got to be whole numbers. Remember this very slide? See that nice little word right here? Whole numbers. Remember, whole is not a negative number. So therefore, if any term in a polynomial can be written as a negative exponent, it's not a polynomial. So I'm not completing this table. Let's take a look at this one. Okay, none of the exponents in problem 2 can be written as a negative exponent. So then, therefore, my terms are going to be -7 k to the 4th, 1.3 k cubed, -8 k squared, and -11. I have got to write the negatives with it. Now, the degree is just talking about the powers of the exponents. Well, this will give me 4. This will give me 3. This will give me 2. And don't forget, the 11 has x to the 0 power. That's a whole number. Okay. Now, this is where it gets a little interesting. Notice that everything here has just one letter. If you look at this problem, everything has one letter. Okay. Well, this is where we're going to have a little change here. Notice that I have 2 letters. Okay. I have 2 letters. Okay. When there are 2 variables, the degree of each term is the sum of the variable powers. Okay. I have 2 letters here. To find the degree, notice, to find the degree, in this column, it's going to be the sum of the variable powers, the sum, which means my terms are x cubed, y cubed, 12 x cubed, y squared. Now remember, I got to write the negative with the xy because that's a term. It's got a negative, and then I have a 5. Now, the degree is the sum of these two, which is 6. It is the sum, and notice it's only the variables. That 12 is a coefficient. That's nothing to do with the degree. This is going to be 5. Now, this one has 1 up here, 1 up here. This is 2. Now, this is where you got to be careful. This is x to the 0. Y to the 0 is understood. But what's 0 plus 0? It's 0. Huh? So the degree of this polynomial is going to be 6, the highest power of the sum of the variables. Whereas in the last slide, when I only have k's, the degree of the polynomial is 4, the highest power of just the single variable. But this one is 6, is the degree of the polynomial. It's the highest exponential power in this table. Okay, we're going to do one more, and this one should be really nice. Okay, we only have one term. Its degree is 5. So the degree of the polynomial is 5. When I have one term, it's really easy. But when I have a whole lot of terms, gotta look for the highest power. When I have 2 letters, I have to look for the sum that comes from the 2 variables. What is my greatest sum? Now, a couple of things that are going to talk about words, okay? And words are going to become real important to us. We want to talk about a monomial. And notice M-O-N means mono, means 1. Okay? The binomial, this end part, this poly means many, that's an N, terms. A monomial is a one-term polynomial. Now, everything here is one term. Okay? Everything here. I should have just written it like this. Poly means many. Nomial means terms. Now, hopefully everybody knows this one. Bi means 2. That means we have 2 terms. Now look at this W plus 2. 4z squared minus 11. A to the 4th minus b to the 4th. And this last one, well, it has more than one letter in each term. Negative 8c cubed d squared plus 3cd. Now, you're going to notice that 2 terms are separated by a plus or a minus. Does it matter? No. Right? Now, there's one more word we have to know. Tri. Tri is 3. Now, this is an example of 2 letters. 6a to the 4th plus 29a squared b plus 28b squared. This x squared minus 3x minus 40 is a trinomial. In my third example, everything has q's. My first example has a and b. Now, I want to show you something. This a is a power of 4. This is a power of 2. Now, I want you to realize that this 28 has an a to the 0. The powers are descending. This is 4. This is 2. This is 0. But notice the b's. And you're going to say, what? Well, this 6a to the 4th has a b to the 0 behind it. This has b to the 1, b to the 2. The b's, or the second letter, is going up. The a, which comes first in the alphabet, its powers are going down. Okay, so when you have two variables, alphabet plays a role. Okay, you use the first letter in the alphabet. When you are writing a polynomial in descending terms, and it has two different variables, alphabet rules. In this circled poly, I can type here, it's polynomial. The powers of A will tell us how to write in descending order. I'm going to make this a capital A. In the circled polynomial, which means in the black circled polynomial, the powers of A will tell us how to write in descending terms. Okay? Now, fun part. We are going to learn how to evaluate. Now, some of you may find that the way I'm going to do it, because I kind of like to do it the wrong way, and there are some reasons that I do it this way, and you'll see why. This is saying evaluate a tri-nomial. Well, that means I should have 3 terms. Well, sure enough, I have 3. I have y squared minus 10y plus 3. 3 terms. Now, I'm going to use this polynomial or trinomial twice. Now, technically, see where these letters are? I am going to write 2 parentheses for this y squared minus 10, and I'm putting my parentheses, plus 3. Inside each parentheses, I'm putting 4. Now, could you have done 4 squared minus 10 times 4 plus 3? The answer is yes. This is going to give me 16 minus 40 plus 3, which is going to give me a negative, okay, this is, I should make that a 24. Plus 3, which means you can write it like this, or you can write it like this. Now, when this is a positive value for y, that works nice. But look at number 2. Do you see I have a negative number? -1 times -1 minus 10 to the -1 plus 3. I like to write this y, because it's a negative term, as 2 negative 1s. Because remember, we've got to keep the signs. This is going to give me a positive 1 plus 10 plus 3, or 14. Okay. So if you tried to rush ahead of me and you got something different, you might find that writing it as I did in red here, that I'm boxing in green, works pretty good. And remember, this is a trinomial, 3 terms. You might have something bigger. And do we want to work with that? Well, that's your choice. Now, as I promised you, we are adding and subtracting polynomials. Now, this is where we have to remember that we've got to combine like terms. And then we have to write our answer in descending order. Now, when this happens, I like to do something called block. Okay, and you're going to say, what's the block method? Well, the block method is I have a positive 1 out in front of this parentheses. Well, this is going to have me distribute, and I'm going to write t cubed plus 4t minus 7t minus 5. Now, do you see that I have a second polynomial and I have a positive 1 in front? To ensure that I write in descending order, notice what I'm going to do. 1 times 6t cubed is going to sit in a block method underneath the t cubed. Before I forget, I forgot my 2 here. Okay. Now, when I multiply right here, this is going to give me a positive 1t squared. But notice this is a sole number. That means when the 1 multiplies by here, I have a -3. There is a space here in my block method. I don't have a second term that has just a power of t to the first. Now, I like this method because I can then just look at my columns and my answer is in descending order. This is 7t cubed plus 5t squared minus 7t minus 8. This my answer. Now, some people like to just go straight across and distribute. Now, this would give me, okay, and this is called the horizontal method, where you're just distributing. This is t cubed. Notice I'm distributing. Plus 4t squared minus 7t minus 5, and then I just continue horizontally, plus 6t cubed I'm going to have to come down here, plus t squared minus 3t. In the horizontal method, I have to know that this term and the one way over here have got to come together first. I then have to recognize that this term and this term have got to go second. Because notice this is the highest power of t. That's the second one. Well, all I have is just this one. And then I have the -5 and the -3, which gives me -8. I have to look across the line. Well, block seems to be better because I can line them up. But that's my choice. Okay? Now, this one. It is saying to add. Okay. Well, horizontally, I'm going to put that right here because I'm going to do that first. I'm going to take this term, which is a squared, and this term, and I'm going to add them together. That's my horizontal method. Then I'm going to take a negative 11a and this positive 11a, and I'm going to write a negative 2a. And then I'm going to take this 3 and this 5 and write positive 8. Okay. Well, notice if I do block, and I'll put a B, I write 9a squared minus 11a plus 3, and then right below it, I write 6a squared plus 9a plus 5. I'm working in columns, which is going to give me 15a squared minus 2a plus 8. Now, this one was easy horizontally. Sometimes it's not always as nice. And this is right here. Now, horizontally, this works really nice. But I have to remember, see that -1 in front here? Horizontally, this is 6c plus 1 minus 4c plus 9. This negative multiplies by a negative. These two terms come together. 2c, and then I have positive 9 and positive 1 give me positive 10. This is my answer. Now, I want to show you something because Alex likes to do this. They put that negative and then they put 4c minus 9. This sign right here on the second row means I have to know to distribute. This becomes a -4. This becomes a positive 9. This negative in front of a second line, you have to know to distribute. This is 2c plus 10. Okay. Now, I like block with subtraction. This term is going to be written -5n cubed minus n squared plus 7n plus 7. Now remember, this sign has to distribute, which means this is a negative 3n cubed plus 8n squared minus 2n plus 4. Watch that negative sign, because now my answer in descending order is negative 8n cubed plus 7n squared plus 5n plus 11. This is my answer. And like I said, I like to make them so that they're in columns. It's easier to write them in descending order, but that's my choice. Okay. Could you just distribute? Oh, sure you can. All right. Now, this one. Okay. This has A's and B's. Well, again, I have to write it in descending order. So I'm going to take this term and I'm going to write 6a squared b squared plus a squared b minus 4ab here. This is going to give me a positive 5a squared b squared. Now this is going to give me a negative 7a squared b squared minus 2ab plus 18. Notice how easily it's nice to write this in descending order. This will give me 11a squared, and that's got a 2 here, b squared minus 6a squared b minus 6ab plus 5. I like to look down rather than across, but that's your choice. Okay. Okay. Right here. Now, notice that this first parenthesis has 4 terms. The second has 3 terms. I'm going to write my first one. 2xy minus 3x plus 4y minus 1. Now, the beautiful part about this negative sign, this will give me a negative 3xy. This will give me a negative 6x. But notice way over here, this is giving me a positive 4. I have an empty space right here under the 4y. This is going to give me negative 5xy minus 9x plus 4y plus 3. This is my answer. Huh? Okay. Now, this next part is just a different way of evaluating. Now, these last 2 slides are asking you to use functions. Now, I want to tell you something. This x that's behind the f, that does not mean that it's f times x. This means f of x. This -3 is going to go in to every x in this problem, but it's how we write the answer. This says f of x. That means I am going to write f of -3 equals -3 cubed minus 8 times -3 squared minus 5 times -3 plus 9. This is known as function notation. Okay? It's just another symbols game. But when I write my answer, it's f of -3 equals -27. Now, this is 9, positive 9 times -8 is -72 plus 15 plus 9. Now, these two are going together, which is -99 plus 24. Because this is written in function notation, my answer is f of -3 equals a negative, in this case, 75. This is how my answer is written, but it has to do with the fact that we're talking functions. It's just a symbols game. This f of -3 is saying evaluate this problem for x at -3. Remember, we did the evaluations way back here? Okay. Let's go back here. Okay. Remember, this says evaluate. Well, I could write f of 4 is equal to y squared minus 10y plus 3. This is saying every x or every y is 4. It's the same process, except here I use the word evaluate. Down here, I use this symbol of f of x. Now I'm going to do one last one. Okay. This is the function symbol, which is saying for every one of these x's, I'm going to put in -2. I'm going to evaluate x is equal to -2. That's what this symbol is saying. But how I write it is saying -2 cubed minus 5 times -2 squared plus 3 times -2 plus 10. It's the symbols. F of -2 is equal to -8. Now remember, -2 squared is positive 4 times a -5 is a -20 minus 6 plus 10. This is going to give me a -28. And if I put these together, it's positive 4 My answer is f of -2 is equal to -24. It's a symbols game. I either use this word and say x is equal to -2, or I write it in symbols. Means the same thing. And this ends section 6.2. I know you're excited. Yay!